Lecture 1. For the following items, you will listen to a lecture about blood types. As you listen, mark the alternative that answers each question or completes each statement. Before you listen to the lecture, you will be given 90 seconds to look at the questions and the alternatives.
Okay, so before we begin our session about blood types, let's review what we know about blood. According to the textbooks, about half of the volume of blood is made up of blood cells that begin as stem cells in bone marrow. And these stem cells can develop into any of the other kinds of cells found in blood, including red cells, white cells, and platelets. White cells are essential to the immune system. Red cells give blood its color, and they're important for what we call blood typing. And blood typing is what I want to talk about today. Now, blood types are a classification of red blood cells according to the presence of specific substances called antigenic proteins and carbohydrates. You can see them under the microscope on the surface of the cells. The 4 blood types are identified by the letters A, B, AB, and O. Blood type A contains red blood cells with the antigen A. Blood type B contains red blood cells with the antigen B. The AB blood type contains both antigens, and the O blood type contains no antigens. But the individual with this type can form antibodies containing either A or B antigens.
Excuse me, is that why the O blood type is considered a universal blood type? Because it can form antibodies with either A or B antigens?
Yes, you're right. But when classifying blood, the antigens are really much more complex than this explanation might suggest. There are at least 300 different antigens. In fact, there are so many potential combinations that an individual's blood type is almost as unique as a fingerprint. But anyway, these basic types are used for determining suitability for blood transfusions. That is, transfer of blood from one person to another. This is why, before a transfusion is approved, hospitals always perform a procedure called a cross-match. Okay, in cross-matching, we take red blood cells from one person and mix them with the plasma of the patient, and we watch to see whether there's a negative response. You see, in almost every individual, the plasma contains antibodies that will react to antigens that aren't found on their own red blood cells. So during a transfusion, when the donor's blood isn't similar to that of the patient, antibodies in the patient's plasma can bind to antigens on the donor's red blood cells. Well, many minor reactions can occur, like fever or chills, but some reactions are so severe that they lead to a destruction of the red blood cells from the donor and can result in shock or even death. Cross-matching lowers the risk of a serious reaction. Here's what you would be looking at with a reaction caused by incompatible, that is, unsuitable blood matching. See how the cells clump together? Well, of course, doctors prefer to use the same type as that of the patient, but exceptions have to be made in emergencies. Type A patients can't receive type B blood, and type B patients can't receive type A blood. Because an O donor has blood that's compatible with both A and B antigens, it's the ideal, or as you said, he or she is a universal donor. In an emergency, type O blood can be used for patients of all blood types. And fortunately, worldwide, type O is the most common, followed by type A. Relatively few people have type B blood, and the rarest blood type is AB.
Professor Stevens, can you tell us anything about artificial blood?
Well, it's a white fluid chemically similar to Teflon, the material that coats cookware. The fluid can match with all blood types, and so the cross-matching stage can be eliminated. So far, artificial blood has done a good job of replacing the red cells by carrying oxygen. It flows through the body, and at the same time, it eliminates carbon dioxide, but there are no white cells present, no antibodies, no platelets, and that's why it can be used with all types of blood. So it doesn't clot, that is, thicken, and it doesn't remain in the body very long. Still, continuing research should probably be encouraged. Okay, going back to transfusions, well...